Hello everyone. In this demo, I'll be showing you an example of AWS-IoT publish and subscribe activity using the onboard physical button and LED on this GL iNet pocket router. These three demo units are programmed with custom-built OpenWRT Linux. For wiring simplicity, each of these router is powered through a 5-volt battery bank, and the internet connectivity is provided through mobile data of external USB modem, which is also connected with a SIM card. Please note, internet to these routers can also be powered by connecting the WAN interface of this pocket router to your local home Ethernet or Wi-Fi. This USB battery bank is sufficient to power these routers for few hours. When I turn on the 5-volt power, as you can see, LEDs on these routers would start blinking for about a minute. And then they are connected to AWS IoT core through the mobile data internet. The power LED of the router will remain on or off condition as per the slider switch position. Now Linux on all three units is done booting and they are connected to internet and AWS IoT core. Now I'll turn on and off this slider switch, and you will notice power LED on all three routers will follow the switch position. This slider switch is programmed to publish its state to a topic called test topic LED, and LED on the router has subscribed to the test topic LED. When slider switch publishes its state, LEDs will receive the notification with a JSON object containing the state of the slider switch, and they turn their states as per the received JSON value. So I can do the same from any of the slider switches, so they will follow their state. So that was about the first example demo, and now I'm going to show you a second demo as explained in this picture. In this second demo, I have configured these three routers as Wi-Fi client to get the internet access through my home Wi-Fi. As you can see, on the USB port of these routers, I have plugged in a USB powered LED light. These USB lights can be purchased online for a few bucks, and they consume around 1.5 watts of power from the USB port. Switchable 5-volt USB power is one of the interesting features of this pocket router. And I'm going to control these USB lights by publishing the state of the slider switch to the AWS IoT core. And these USB lights will follow the state of the slider switch, as you can see. And I can control these lights from any of these three slider switches. So that was all about second example demo. In the third example demo, as you can see in this block diagram, I'll be using this USB based volume control knob to generate the publish events and blink one RGB LED indicator as a subscriber to show the status with different LED colors. This USB volume control knob And blink 1 RGB LED indicator can be sourced from the online shops easily. This USB volume control knob shows up as a standard keyboard event device in the Linux space of the Pocket router. And blink 1 RGB LED dongle would show up as an USB HID device. As you can see, I have configured first unit as a publisher to AWS IoT core and remaining two units as subscribers. In a real-world application, this setup could be used to show the availability status of a remote entity to multiple clients, which are distributed at different physical locations. Or, for example, it could also be used to distribute the status of your Jenkins build jobs at multiple locations. Pressing the first button would trigger these LEDs to change their color to red. Similarly, second button would turn the LEDs to turn green, and the last button would turn LEDs to blue. Also, I have mapped the mute button to toggle the LED state. So that's all about the third example demo.